Hey, Ryan, good morning.
Morning.
All right, it looks like Pavel might be having difficulties joining. All right, give me a second. I think one of the panelists is having some technical difficulties. Give me a second. Hopefully we'll sort this out soon. Sorry for the delay. I'll address this soon in a few minutes. Yeah, I think there are a couple of questions about recording. This will be recorded and it'll be uploaded to our YouTube channel, hopefully in a few days, but I'll address it as we get started. Just want to make sure all the panelists are here. And sorry for the delay. And wow, we already up to like 70 plus people, which is amazing. All right, looks like we have panelists on board. All right, sorry for the technical difficulties. Thank you, Igor. Thank you, Pavel, for joining. We'll get things started. I think we're live on YouTube live stream as well. Thanks for confirming that you can see the slides. So we have a slide set, but obviously this will be like interactive and hands-on as well. Just as a quick introduction, I'll let the panelists introduce themselves too. My name is Ray Paik, and welcome to I think this is our first event outside of monthly community calls. So we're obviously very, very excited and thrilled to see 70 plus people joining us from, looks like from around the world. So welcome. And hopefully this will be first of many sort of technical hands-on workshop that we'll do in the future. And obviously pre-aggregation has been a pretty popular topic in our marquee feature. So we thought this would be a good topic. And based on the number of registration and people dialing in, we're pretty happy with the choice. So yeah, we'll get started here. And as you may know from our monthly community calls, we do have a code of conduct at Cube.js community. And we want to have a welcoming and open environment. So if you want to see details of our code of conduct statements, you can go to our repo, take a look at details, and let me know if you have any questions. And some quick notes before I turn things over to our speakers is, many of you may have done other Zoom webinars. So if you have any questions, I mean, you can obviously type it in chat as some of you have already done, but you can also use a Q&A function. And all of the QDev team members will monitor those questions as they come in. And what we plan to do is at the end of each section, agenda section, we'll pause and address some of the top questions that we have and before jumping on to the next one. So don't feel like you need to wait all the way until the end. We built in some ample Q&A time at the end to answer your questions, but feel free to type your questions as we go along, and then we'll monitor them as the speaker is covering their materials. And you may also notice, I sent an email a couple of days ago and announced it on various social channels. We are using Cube Cloud today for our hands-on exercise that Ryan will be walking people through. This is obviously a product that hasn't been launched yet. I think some of you may have had access to it via our early access program. So some of you may have had a chance to use it prior to the talk, but this is something that's going to be GA in a few months. But we thought, I mean, this actually provided us with a nice way of sort of provisioning an environment for a tutorial setting. So hopefully you get a chance to take a look at the Cube Cloud product that we're building, and get some experience using pre-aggregations as well. And as some of you already asked, this session is being recorded. Actually, it's being live streamed right now, but it will be posted on the YouTube channel. Unless there's any edit required, it'll only take a day or two to get posted online. Because I do realize there are people who signed up from countries like Australia. It's like at 2 a.m. right now, so I doubt those people are able to dial in. And if you had any colleagues who are not able to attend the call, feel free to pass on the link so they can follow along. Also, after the event, you'll receive a post-event survey. It's a short, like a 5 or 6 question in Google Forms, and it'll really help us with your feedback on how we can plan future events. In particular, there's a question on what are the topics you want us to cover in future workshops. We do have some sense based on the questions we get. But we also have the option for you to sort of type in other topics that we haven't listed there. So your feedback would be valuable for future workshops. And you may have seen a social post like last week. Everybody who's joins our call, looks like about 80 plus of you, you'll have a chance to receive your pair of Cube.js socks. And if you want to, you can just provide your a shipping and shipping information in the survey as well, so you don't have to deal with another email from me regarding the pair of socks. And I'm not wearing it today, unfortunately, but I should have, so I can demonstrate it. But we're pretty confident that you'll like the pair. It'll be a nice addition to your wardrobe. So. Cool. Without further ado, let me. I'll discuss the agenda real quick, and I'll turn things over to Pavel. So we invited Pavel, who's our CTO and co-founder of CubeDev, and sort of father of Cube.js pre-aggregations, if you will. So what is to talk about, why pre-aggregations and, what makes our pre-aggregations different. And after that, we'll turn things over to Ryan, who will go through the live demo, and you'll have an opportunity to sort of follow along hands-on on Cube Cloud. And we'll discuss the tips and tricks, particularly in the production environment and resources and the Q&A. And like I said, any Q&As, feel free to, it looks like several of you have already typed questions already. Feel free to do that, and we'll monitor them as we go along. So without further ado, Pavel, I'll turn things over to you. And if you like, I can just advance the slides so you don't have to share your screen, if that works.
Yeah, that works. Yeah, cool. Thank you, Ray.
Yeah.
I really just would like to give you a really brief introductions about why pre-aggregations, why do you need those, and also just what they are. So for those who are already users of pre-aggregations, this can be kind of obvious, but just wanted to give a highlight because people ask us a lot about what is it, and just 5 minutes highlight. So to start with, why do you need pre-aggregations? So basically, pre-aggregations solve mostly the performance problem of your application, and the reason for it, data is growing every day, and to catch up with it, you would need to build really fast and responsive and also cost-effective applications, given we are living in a world of cloud data warehouses. So it's why basically pre-aggregations make sense. Yeah. If we go to the next slide and talk about a little bit what is it pre-aggregation. So essentially it is cache, but it is like a smarter cache. We've asked about for newcomers, newcomer pre-aggregations users, usually asks us if we download all the data into memory, serve those from memory. No, it isn't the case. And pre-aggregations are much smarter than that. So this is actually a condensed version of your data. And essentially, so when we condense this data, so as an input, we can have like millions of rows, and output rollup tables, which is most used type of pre-aggregations, are usually much smaller. And this allows us really to cut the cost of data access, from like dozens of times to even thousands of times for specific queries. Yeah, and if you go to the like example of pre-aggregation data, pre-aggregated data. So as you can see on the slide, so how we can make this happen. This is a really simple example of like orders. On the right side, we have orders with order IDs as a raw data table, and we have products there. And let's pretend we want to know which product in terms of quantity. Oh, Ray, can you please refresh this page? I think you have like
oh, sorry,
like an old version. Yeah, just some glitch with Google presentation.
all right, sorry.
Okay, cool.
Yeah, sorry.
Yeah, so and the thing is, on the left side, you see the raw data, and let's pretend we want just answer queries like how many ice cubes we sold by month, and or how many like products in total we sold by month. And right table answers all those questions. However, it has only like 120 rows instead of like 1 million if you have like raw data, for example. And this is like mechanics behind that is a multi-dimensional analysis. You can learn more in our documentation. We have some links to external sources, but the idea so that some function, aggregation function, is decomposable, so you can sum it like on various level of dimensions. So if you can see like ice cubes in July, like sums like 4 and 2 sums to 6, and it's obviously like you can get this result if you're aggregating by months or aggregating by product. Obviously, you cannot get order ID from this table after you pre-aggregate the data, but this is a trade-off you get when you're using the pre-aggregations. Yeah. So if we are going to the next slide and just talk about how like this pre-aggregations approach is usually adopted, and if you're basically trying to implement your bespoke customer-facing application, usually like will be in a position where you're starting without caching at all, and as you're going forward with production, so you start seeing like problems at serving bigger tables. And what we usually see, all the approaches like to build this solution like pre-aggregating data in-house mostly fail. And usually it's too much to spend in a smaller organization in terms of like time effort. We see a lot of like this approach isn't new, and it's used by bigger companies, like for example under the hood of Google Analytics or Mixpanel. So and it's why really yeah, if you go to the next slide. yeah, so, and it's why you probably would like to use pre-aggregations. So it's basically speed up your queries, and it's the first goal you want to achieve here. And also it reduces data processing cost. This is especially significant when you use cloud data warehouses, and you need so every access, if you know, like BigQuery or Athena pricing models, or even Snowflake, if you know your pay there for data access, and every data access like to raw data costs you much. However, most of your users of your applications, most likely for 90% of their queries, don't need to access raw data. And that's why pre-aggregations can like cut your costs a lot. Yeah, and again, so save your engineering team days and weeks like of work and effort, because it's like to build in-house, like it's really tricky to do. So yeah, and going to the next slide. So why like Cube is very well suited to build this like basically pre-aggregation layer and caching layer. First of all, if it's an API, and basically what we figured out and what we spotted from our usage and feedback, API makes like Cube.js API makes basically all the interactions with data sources in general, and also pre-aggregation transparent for users. So, and if you build an application which is, for example, served by actually raw data at the beginning, so, and you already built your application, front-end code is in place, you have all the charts, but you have like you start seeing all the performance issues. So you can introduce pre-aggregation layer transparently for your users, so you don't need to change any front-end code usually. So that's the one thing. And also this one is used to replace even data sources of pre-aggregations if you want, for example, to migrate from your Postgres data warehouse, or it's like, or your OTP database, move to, for example, BigQuery or Snowflake eventually. So this one works as well. And the second thing is a Cube Store. And it's Cube Store is basically a layer we designed to store and serve pre-aggregated data. It's designed to store really like high cardinality roll-up tables. So we are aiming for like billion roll-up tables here. And the thing is, Cube Store allows you to and the storing cache to do not depend on pre-aggregation complexity. So if you obviously introduce some complex pre-aggregation, and basically the pre-aggregation is complex and it takes a lot of time to execute and build, but serve time doesn't depend on it. And also what we're trying to do, that serving time doesn't depend on data amount itself, which is usually like really tricky to solve. Yeah, and if you go to the next slide, just like a brief overview, like the simple architecture, you've probably seen it from our blog posts. So how we achieve this basically decoupling on the server side. The thing is, there are multiple layers in our architecture. So you have API instances which basically solve only one problem, and it is serving traffic and fulfilling user requests. An actual build process is done by refresh workers, and we have like caching queue in place, which is basically allows you to schedule all the workload in terms of like pre-aggregation building. But actually Cube API instances, if you're using this architecture, not involved in this process anymore. Yeah, in last several months, we were working hard to achieve this like really high level of decoupling. And also we did a lot of modifications on how traffic is served. And if you're using Cube Store, which is now by default, all Cube API instances are using shared nothing architecture, which wasn't the case just like several months ago when it was using Redis to serve the traffic. Right now, if you're using Cube Store, Cube instances doesn't rely on Redis anymore to serve traffic for cache, like for pre-aggregated data, which basically allows you to virtually basically unbounded horizontal scaling in terms of Cube API instances. Yeah. So yeah, obviously this is like really brief overview of pre-aggregations, and we are going to discuss a lot of hardcore questions after our presentation. But yeah, so thank you for your attention, and we'll discuss all the like your questions just a little bit later. Thank you.
Cool. Thank you, Pavel. Yeah, I've been looking at questions on Q&A. Ryan, you probably see them too. There are a couple. I think they're related to like particularly about ClickHouse. I'm not sure if you want to address those before we move on to your hands-on workshop, or how do you want to do them, Ryan? Or should we just start with your live demo first and then address these questions afterwards?
Yeah, I guess if there are any follow-up questions on what Pavel just discussed, we can talk about those. But I think let's start with the demo actually.
Yeah, because I think some of these, questions might be addressed, is what I was thinking.
Yeah.
So all right, so let me stop sharing, and then Ryan, obviously you'll take control, and we'll go from there.
Sounds good. So I hope everyone here has created their first deployment on Cube Cloud. We sent out a message earlier giving instructions on how to create your first deployment and how to connect to a database that we've hosted, an Aurora Postgres database. So that's what we'll be using today for this kind of demo, which I hope all of you can follow along with. Just to note, those of you who may be running Cube.js yourself locally or hosting it yourself, you can actually also follow along with pretty much all of these steps as well. There's just some really nice features in Cube Cloud around visibility with respect to pre-aggregations and with our queries that we'll be running that will make it very nice for us to show here in this workshop. So the background here is, let's imagine we are an e-commerce business and we have a very large data set. Let's say an orders table that is, I think this one is about 30 million rows of data. So we have, let's say, about 5 years of data, and it's obviously a very large data set, and we're trying to build some applications that surface this data to our users. And I'm actually curious, we didn't ask this question in the survey of how large everyone's data sets are, but if you'd like to volunteer, if you are in the millions or tens of millions of records in your data as well, please share that in the chat. We'd be interested to know. So let's first run some queries, and just to make sure y'all can see my playground, right? This is a feature that is also an open source, of course, and is heavily used. So we're going to run a baseline query first. I'm going to take, I need to move some things out of the way on my screen. Order status as one of the dimensions. The count of orders is going to be our measure, and we're going to also take creation time as one of the dimension, as the time dimension. And let's run this query for this year, and let's group it by week. Okay, so run that. And I hope all of you are following along as I mentioned earlier. So this is going to take a bit of time because obviously we haven't added any pre-aggregations. And actually we can check, well, if you're interested to know as well, this is what the SQL statement looked like that we ran. But we can also check out how long that query took. I'm just going to say in the last 15 minutes. It took about 9 seconds to run that query. So that would be that wait time would definitely be noticeable for our end users. Let's see what we can do to potentially speed that up a bit. So let's go back to Playground and run that query again. And this time we're going to click up here in sort of the upper right where it says query was not accelerated with a pre-aggregation. And this is going to bring us to a feature we call the rollup designer. So this is also a feature that is usable on open source Cube.js as well in Playground. Called a rollup designer because we sometimes call pre-aggregations also rollups because pre-aggregations by default are of the type rollup, and that's by far the most useful type of pre-aggregation. But basically what this is enabling us to do is to create a kind of pre-aggregation definition without actually having to write any code, which is really nice. So this is the query that we just ran. So you can see there's the count measure, the creation time is a time dimension, and also status is a dimension. And so the rollup definition would be in this screen here. If I were to change this, let's say I remove status as a dimension, well, that would mean that the resulting pre-aggregation would no longer include status as a dimension. And it's also letting me know, okay, this pre-aggregation no longer will match that query that I just ran in Playground. So just be warned about that. We'll just take the pre-aggregation that was originally suggested to us. And I'm going to call this my first pre-aggregation. And then I'm going to add that to my schema. So this button here. You'll notice that granularity is in days. When we ran, the query we ran was grouped by weeks. There's a reason for that, and I'll explain that in a bit. But first, let's take a look at the pre-aggregation. So we should see that notification, which I X'd out, sorry. But a notification that that pre-aggregation was added to our schema. So if we now go to our schema view, oh, and you'll also notice, for those of you who are new to cloud, there's two different modes that the schema and the API can be in. We have a development mode and a production mode. So whenever you're editing the schema, like we are now, we'll be switched over to development mode. And basically this creates just a feature branch where we can be, editing our schema without fear of interfering with production. Okay, so in the pre-aggregation section, we see, okay, great, our first pre-aggregation was added here. Now we can also take a look at the pre-aggregations view and see the first pre-aggregation there. It's not built yet, so we could go in here and build it from this screen. So this is going to take, I expect about half a minute. But basically what's happening here is we're building this pre-aggregation and loading it onto KubeStore so that our future queries will be able to make use of this data. I'm just going to quickly check the chat, make sure are able to follow along. Looks like we're pretty good. So yeah, now this pre-aggregation should be built. Yeah, it looks like it took about 34.5 seconds. You'll notice this says automated refresh is disabled in dev mode. Don't worry about that. We'll talk about that in a bit. Oh, I guess, yeah, let's go back to Playground. So now if we run this same query, it should be, wow, I just clicked the button and the data came back, the results turned back. So that was lightning fast. You'll see, okay, query was accelerated with pre-aggregation. Great. So if I can actually inspect how much time that took. If I go back to my queries tab, and voila, it took about 1/10 of a second now to run that query. So a much better response time than for earlier without the pre-aggregation when we were, I guess it was 5 seconds the last one and 9 seconds before that. So that's really neat. Now, going back to the pre-aggregation, let's take a look at actually what data is in there. So I'm in the pre-aggregation section, and there's a couple tabs down here. There's the partitions tab, and we'll discuss what partitions are in just a second. But we can take a look at the preview. Actually, you can take a look at the definition as well to see how it was defined, and you can also preview the data here. So similar to that table, that simple table that Pavel showed you earlier, this is how the data, the condensed data, it looks like, right? We have the dimension of order status, and then basically for each day, we've created a count of the orders. Now, some of this data, so you might be asking yourself, okay, so this pre-aggregation contains data that would likely need to be refreshed, right? My business is still in business, right? Orders are still going to be coming in. I can't just have this pre-aggregated data just sit here, right? But I also don't necessarily want to refresh all the data in this pre-aggregation all the time, right? Some of this data, like from 2018, I would probably consider that historical data. I don't need to touch these records in the table. It's only for data in maybe up to 3 days ago that I might need to adjust things. And then I'd also want to add more data on top of it, right? Obviously. And so that's where we introduce the concept of partitions and refresh policy. So let's go to our schema. And we're going to add partitions to this data. So this is where you all will follow along with basically adding some code here into the pre-aggregation definition. So the first property I'm going to define is called partition granularity. That's partition, P-A-R-T-I-T-I-O-N G-R-A-N-U-L-A-R-I-T-I. Y, sorry, I know spelling is hard. And for this, I'm going to set a month. So what I'm essentially saying here is so a partition you can think of as an increment or a shard of the data. And the partitions are essentially sharding your pre-aggregation into multiple tables based on some attribute, which in our case is the time dimension, the creation time. And each table will represent a month's worth of data. Okay, we're also going to add a refresh key. And for that, I'm going to say, let's do it every 1 minute, which is very frequent, but for the purposes of this demo, we want to see this in action, right? So by default, this would just be an hour if I left this blank, and that's like around the time that we would expect most use cases to need. I'm also going to set this to incremental true, and I'll explain what that is in just a sec. And I will also set an update window of 3 days. Now, so the incremental true property essentially is saying by default refresh the most recent partition. The update window property is saying that go back for whatever amount of time falls within or go back 3 days and whatever time that span that is, if that falls within any of the partitions time spans, also refresh those partitions. So I set 3 days because again, I'm an e-commerce business and I really only expect orders to be, say, updated within the last 3 days every now and then. So that would mean effectively here that I've partitioned again my data by month. So only the last month, only one partition, the most recent partition should be updated. And actually, this data set, it's fabricated data, of course, but we also have some future data in it, some made up data that represents orders in the future. So I want to only have the pre-aggregation cover the data up into the present. So for that, I'm going to add another property, build range end. There's also build range start. But for this, I'm going to define with SQL, and I'm going to use a SQL statement for that. I'm just going to say up until now. Okay. I'll just stay on this screen for a little bit, so those of you who are following along can make sure you have these as well. So what I did there essentially is set a end date for my pre-aggregation in terms of how much of it will be built, which is today or right now. By default, if you don't set the build range end or build range start properties, those will just take the min and max values of the time dimension. So essentially your entire data set will be covered. But like I said earlier, I want to make sure that I'm only building this pre-aggregation up to the current time. Okay, so I'm going to save that. And then you'll see, okay, the API is restarting. So that's, but that's again in development mode. So if I go back to my pre-aggregations, should see this start to refresh, which it is. And the partitions should now reflect a much bigger number than 1. Looks like it's 44 partitions. So that means that there's 44 months roughly worth of data here. And if I click into it, okay, so now we see all these partitions per month. And we also, so we don't have the refresh policy. We don't have the refresh policy in effect because we are still in development mode. And so we'll cover that in a bit. I want to show first several ways that you can build these partitions. Okay, so let's take 2 months at random. Let's say April and March. And those of you following along can also do the same. Please don't build all of the partitions all at once. We while we should be able to handle that, if everyone did it at once, we may be testing our luck with the database gods. So let's all just pick one or two, and we'll build those. And this should take less time than the 35 or 30 seconds that it took to build the pre-aggregation in its entirety. Oh, it looks like April's already done. Oh, maybe not. So April took 11.5 seconds. I think March is going to follow soon after. So now, effectively, we now have pre-aggregated data for April 2021 and March 2021. And if I go back to Playground, I can see that this is true by now performing that same query, but we're going to use a custom time range now. So let's do the query on April. I'm just going to do these weeks. Yeah. Run that. Okay, yeah, the query was accelerated pre-aggregation, and you could see that was very quick, right? Now, if I pick a different month, so let's say May, and I didn't build May yet, it'll still say that the data is pre-aggregated in the status, but this will also trigger the build of the pre-aggregation, or the partition pre-aggregation. So you can see, okay, the query is taking a little bit longer, but it's what's happening here is that we're building that partition for the month of May. And yeah, so that probably took about what, 11 or 12 seconds. So it still says it was accelerated pre-aggregation, but it obviously didn't seem that accelerated. But the next time I run that same query, it'll have, you know, the very fast return time that we were seeing earlier. I realized I didn't dig into the SQL a bit yet here, but you can see if you select the SQL button here on the right, that we are now pulling in data from these pre-aggregation tables. So this is useful to know if you'd like to kind of dive in with SQL and start to inspect what's going on behind the scenes. Okay. So yeah, that's essentially partitioning. Now let's talk a little bit more about the refresh policy. And for this, now we can go back to our schema tab. And let's commit and push this. And you can, so it's the button on the upper right, and you can add whatever message you want. Let's say test, and then I can commit and push. So the reason I'm doing this is because I want to leave development mode and get back to production mode so that we enable the refresh, the automatic refresh to happen. So if you go back to the pre-aggregations right now, it'll show no pre-aggregations. Don't worry, that's because we still have to see this schema kind of deployed for our production environment. So if you go back to, I guess we haven't gone to this screen yet, but the overview screen, this will show me the status of my Cube.js builds. So we're deploying the build now. I'm just gonna give that a second to finish. Or I might be able to see the pre-aggregations already. Yeah, okay. So it's still deploying, but if I go and look at this pre-aggregation now and see the partition view again, we should see within about a minute this partition for August 2021, which again, we set a refresh policy, which would essentially mean, oh, there it goes. So it's automatically refreshing now for the month of August. And I expect this will take about, well, I guess May took about 17.5 seconds, but somewhere around 12 to 20 seconds maybe. And this will be going on every minute now in the production environment. So that's essentially the refresh policy. Some things to know about what we just talked about. Cube generally limits the build of partitions to only 2 concurrent partitions for Postgres. It depends on your database type. Something to know about building partitions, building pre-aggregations, is that this does depend on how you set your policy, how often you want to refresh and build. Will depend on the concurrency limitations of your database. So for Postgres, we generally only set 2 partitions at a time. But in general, you can increase that. There are ways to customize that. So that's something to know. Now, so that we covered partitions and refreshes. I guess some other things that are useful to see here. So we talked about the definition of the pre-aggregation. There's also ways to preview the data, and you can also in here select the partitions that you want to look at. And also take a look at which queries were using this particular pre-aggregation and kind of see the times that those took. We're not going to cover indexes, but this is also a way to kind of increase the performance for things in particular, like where you have high cardinality data. We're not going to cover that in this workshop. We might cover it in the QA. So yeah, these are some neat features of the pre-aggregation view in cloud. Also go back to the queries page, and I can explain some of the features here as well. I can filter here by, queries that, let me increase the time range. I can filter by, queries that did use pre-aggregations or did not. I can also check out the queries happening on the database, basically the SQL statements. And you can see here, we're creating these tables in the pre-aggregation. We're also running the select statement every once in a while. That's the select now statement, because if you recall, that was how we were determining the build range end time, is by using that SQL statement. Okay. So jumping to a slightly different topic, and this is where y'all don't have to follow along anymore in terms of coding. This is a different environment that we've set up to show you how roll-up joins work. So roll-up joins essentially is for when you want to create sort of like a pseudo pre-aggregation that joins data across multiple databases, for example. So in this example, I have 2 rollups, one for companies with the dimensions of company name and size, and then another for users. Users with the measure of count and dimension of the company that the user's at. And then I've defined a roll-up join here, which I have to specify as type roll-up join, because that's different than just a normal, the default type of pre-aggregation, which is roll-up. And then the measures and dimensions using user count, company name, company size, and then also defining the roll-ups that this is joining. So with that, I can go and see, okay, this is a query that I'm running for user count on user company. And actually not sure why oh, there we go. So this is running the query with the just a single pre-aggregation. And you can see in the SQL statement, yeah, we're just taking data from one of those pre-aggregations. Now, if I use, let's say, company size, the query is going to change, right? So now we have an actual join between these two rollups. And I should be able to run that as well and also see it was accelerated. So yeah, so now I can see, okay, here's my user accounts for large company sizes, small and medium. So that's the concept behind the rollup join. I should note that as of now, across database joins, we only support right now using the same database type. So it has to all be within Postgres, for example. We can't join Postgres with Mongo, for example, yet. But that's something that we're looking into and we'll hopefully have as a feature as well soon that's supported. Okay, so that was pretty much the workshop portion of it. I hope that was interesting for all of you. Next, I want to cover a few tips and tricks of the trade.
Yeah. Hey, Ryan, so
yeah.
we got a lot of questions, so I think we might want to address a few of those. And I mean, thanks for doing this. So we want to give you a chance to get a drink of water or something. You've been talking for at least 30 minutes. And then, yeah, I mean, hopefully people were able to also follow along. And I mean, if you had any saw issues or glitches, I mean, let us know, either chat or even after the session as well. Hopefully things went smoothly. And yeah, thanks again, Ryan, for doing this. And we got a few questions that we'll address, and then we'll jump into tips and tricks. Actually, somebody asked a question that was going to be covered in one of your following slides, which I made a note of. But I think, Pavel, a couple of questions that came up regarding multi-tenancy. And so if you want to, maybe we can start addressing that first and maybe address a couple of others, and then we'll go back to Ryan. But
yeah, sure. So yeah, I see a lot of questions around multi-tenancy, row-level security, and all of related questions regarding pre-aggregations. So yeah, so the short answer, pre-aggregations are compatible with multi-tenancy, and there are several ways you can approach this. First of all, if you want to reuse pre-aggregations among different tenants, so you probably want to use so-called query write. There is a function. I'm not sure if I post this link to docs in the chat. If you can see those or not. Yeah, let me Google this one. So the query write allows you to basically add some filtering during query processing just before it was being executed in the database. And if you're using this one, you'll be able to add filters based on your security context, based on your application context. And this way you can achieve row-level security and still reuse pre-aggregations. This means you'll have tables of pre-aggregations which will store data for all the tenants. This one is most cost efficient. However, not all security compliances allow to do that. As an alternative, what you can use, you can actually introduce multi-tenant environments using Cube.js multi-tenancy. And in this case, you'll be creating pre-aggregated tables per each tenant, and those will be stored separately, physically separated. And you also can use blended approaches, which we see most of our users do, is when you have shared environments for probably smaller accounts or where you don't need to strict security compliances, and where we see also another way we see dedicated accounts where you have, for example, single tenant and pair pre-aggregation table. So you can mix those in general. Yeah. So I hope that answers the questions. I saw a lot of like smaller questions. So let me address those. Is pre-aggregation possible for rolling window? So short answer, yes, we are working on it. So right now you can even build a rolling window rollup. It's not yet in docs, but we'll be updating those. The only thing which is not supported is a combination of regular measures and rolling window measures. And I hope we'll ship it soon, within several weeks. Yeah, there's also a question regarding if we support pre-aggregations for joint cubes, and Ryan just went through it. So we do support, however, it's supported only for same type of database. Okay, let's see what else.
Yeah. I think there were a couple of questions on using SQL plus every together. I'm not sure if you want to address those now, but
which one is that?
Using SQL plus every together.
Oh yeah, yeah. This is that's a great question. So yeah, there is an issue on GitHub, and so yeah, we plan to add support of SQL and every together, and I hope we will be able to ship it soon. At least I think like probably this quarter. Yeah.
For those of you who are wondering, that's referring to the refresh key that we were just talking about,
yeah,
and adding this a SQL statement instead of just a plain every property to your refresh key, so that you can actually use SQL to determine when the refresh policy is set.
Yeah, correct. The way it would work, so it will check SQL statement every like parental defined in every statement here. Yeah, there also were questions. Yeah, it's regarding if this is really great and really deep question. Can you go over how to create pre-aggregations which will also speed up queries which may have multiple filters applied to them? And we probably covered it later today in a section with tips and tricks. But short answer, you can like optimize this stuff a lot using indexes. And if we'll have some time, we'll cover indexes of pre-aggregations on a Cube Store side a little bit. Okay, what else?
Yeah. Yeah, I think there was another question that I think Ryan's going to cover. So maybe we'll go through the tips and tricks section, and hopefully that will address several of these questions, and then we can take another pause in 10 minutes or so. So Ryan, if you're okay with that. So
yes. Okay, so let's go back to the slides. Just going to go over a few FAQ questions first. When does it make most sense to use a pre-aggregation? So that's a great question. Well, some different types of members or of measures are definitely easier to work with, I would say, with pre-aggregations. And those include count, sum, max, min, count distinct, which we use count distinct approximate for, which I'll explain in a bit. But these are essentially measures that these are additive measures is the term. which means that they can be added together. So a counterexample may be a good way to explain this. If you take average, which is actually a more complicated or more calculated measure, that's doable, but still a little more complicated to set up with a pre-aggregation. Count distinct. So that's also something we often need in our queries. What Cube.js does is we use special SQL backend dependent functions to basically estimate these distinct counts. And we typically use some algorithm like what's called hyperlog. So wherever possible, Cube.js will use that to really improve the calculation time of these distinct counts. And these count distincts end up being estimates, but should be very close estimates. So in general, it's trickier when dealing with these calculated measures, or also with, for example, cubes measures and dimensions that have one-to-many relationships with other measures and dimensions. And we can go over some of those distinct or unique use cases, I guess, in a future workshop as well. Or if we have time, we can talk about those in depth here. And then how do I increase the chances of my queries actually hitting a pre-aggregation? So instead of going to the source database and performing queries on raw data, I want to increase the chances that my queries will actually return results from my pre-aggregated data. Well, the very, very high level rule of thumb here is, well, the more dimensions and the more measures you define in your pre-aggregation, right? So this was a pretty simple data set. We didn't have that many dimensions and measures, but the more I add here, the more that pre-aggregation will cover. That does, of course, mean a larger pre-aggregation data set. And so there's that trade-off, right, of making this a larger pre-aggregation to cover more queries, right? But if you have a use case where your users are going to be performing a lot of ad hoc queries, it's really going to be hard to predict like what they'll be searching by, for example, or querying by. Then it may be best to do that. You can also add more pre-aggregations. You don't have to have everything all in, everything aggregated in a single one. Some other things to know is that the time dimension and the granularity of the query have to match the pre-aggregation itself. Oh, let me make sure I didn't save. I didn't save that. Okay. But so, so recall that when we built this pre-aggregation, it used a granularity of day, not week, even though I was running the query by week. And the reason for that is because the start and end times of each unit of your time dimension will need to match the query's start and end times, right? So weeks are the one granularity type which are trickier to work with because not all. Let me give the general use case as an example. So we created this pre-aggregation based on days, right? So that means if I were to query by hour, right? I'm not going to get, I should see we couldn't use that pre-aggregation, right? And that's true, right? Because the day is not granular enough to cover that case. But if I cover, let's say I do, I'm trying to remember which partitions we built. Oh, it looks like we built a lot of them. So I can query by, let's say, from May to July, and I query by month. That will be accelerated because days are a unit of granularity that fall within a month. The reason why we didn't use weeks is because weeks don't always start and end on the start and end dates of months or years, right? Which are the larger granularities of time. And so weeks are always trickier to deal with. It also, you know, it can be confusing of whether a week starts on a Sunday or a Monday, depending on what calendar type you use. So we generally avoid weeks for granularity, but as you can see from this example, any time granularity that is basically a larger unit of measure can cover that the pre-aggregation will have that query covered. Okay. Also, the order in which your pre-aggregations are defined matters in the schema. So if I were to start adding my second pre-aggregation here, right? Any incoming queries would first be checked against my first pre-aggregation and seeing if that's a match. And then if that doesn't match, we would go, Cube would check the second pre-aggregation that's defined. So just something to know about the order of pre-aggregations in your schema as well. Hopefully that tells you a bit about how you can kind of increase how you can optimize your pre-aggregations, how they're defined such that you maximize the chances of those queries actually hitting them. I also want to cover some of the things that you should probably have on your checklist when running in production. So most of these things you don't have to worry about if you're running on Cube Cloud, because obviously we do this for you. But as Pavel mentioned, Cube Store was really built for and optimized for this use case. So that helps get around some of the latency and concurrency issues that you may see with various database types that would make them bad candidates for storing pre-aggregated data. Also cost concerns, right? Like if you're processing this data every time you're running a query on one of those database types that charges you by the processed amount of data, that can be quite costly. Some other things to have, so dedicated refresh worker, a dedicated Redis instance, these are all to help with scalability, right? We don't want to have to run everything on the Cube server instance. And actually in cloud, you'll see that you can, here, you can set single instance or cluster mode for the deployment type. So most of you, I assume, will be in the single instance mode. But if you were to run in cluster mode, this would create instances of Cube, of the refresh worker and the Redis cache, which would be dedicated instances. And then batching and exporting data. So batching is something that, it's one of these tabs, yeah. Batching is on by default. There's no configuration required for this. And this is enabled for Postgres. It depends on the database type, but Postgres should have this. So to illustrate what happens without batching or export, right? All this data that's being consumed to build pre-aggregations would essentially be loaded into memory on Cube before being written to Cube Store. And if that's a large data set and it's like around 100K rows is where we start to see problems, then that's where Cube, the node runtime on Cube will start to run out of memory. So that's why we have batching as a means of kind of freeing up the memory available on the Cube.js instance. And that's essentially just sending compressed CSVs to KubeStore. Export is another thing that has to be configured, and it's for certain database types like BigQuery and Snowflake, a few others. So this is essentially setting up external cloud storage where you will be materializing that data instead of loading it onto Cube.js directly. And that also is another way of kind of preventing memory overload on Cube. And so that's batching and exporting. Then, as we just discussed at length, like tuning your pre-aggregation build and refresh times, that's always something that you may not get perfect on the first try, but you'll see, and in Cube Cloud, we have a lot of tools available at your disposal to kind of inspect, what queries are going on, what's happening on the database side, so that you can see if your pre-aggregations partitions are not being built at their expected times. And so you can start to tune your refresh policy and the size of your partitions, for example, or anything like that, that would help with making sure that you're continuing to serve non-stale data to users at optimal query speed times. So yeah, those are some tips and tricks that I hope were helpful. And we can start to cover any other topics, I think, that we didn't cover yet.
Yeah, thanks, Ryan. And yeah, I've been monitoring some of the questions, and yes, apologies if I inadvertently, quote unquote, dismissed your question. I meant to mark them as done, so please don't take it personally if I made a mistake. So I think a lot of the questions were answered by Pavel a few minutes ago. I think there were a couple more questions that Pavel, I think one of them was regarding, let me see. Give me a second. The time zone difference and pre-aggregations. Not sure if that was addressed. If you want to quickly talk about that, that would be great.
Yeah, yeah. There was a question: how does pre-aggregation handle time zone difference? Yeah, really great question. So right now, like short answer, each time zone would have its own pre-aggregation table. And the reason for it, especially for daily or weekly pre-aggregations, there is no way to derive, for example, daily pre-aggregation data in one time zone from daily pre-aggregation data in another time zone. I guess in future we are going to separate deriving those from hourly data. However, there are also half-hour time zones, like in the world there are several of them, which basically doesn't fit this pattern well. But yeah, in general, we are going to support our hourly deriving for those. Yeah.
Cool, thanks. And the next question I'm looking at here, in either you, Pavel, or Ryan, I think either you could answer this. Are there any limits on the number of tables in pre-aggregations? Tables created for pre-aggregations?
Yeah, yeah, great question. So there are a couple of limiting factors here, and one factor is the size of amount, like count of tables in source database, and right now, and it's related to another question, how like Cube.js stores pre-aggregated tables, and why do I see those in my source database? Like originally, by default, Cube.js was using the source databases prior to download those to Cube Store. Going forward, we are going to switch most of our data sources to read-only mode, so you don't need to give write access to Cube.js in order to use pre-aggregations. So those will be downloaded like using in-memory approach. And yeah, for some of those which are like bigger data backends, we will be supporting supporting unload stuff, as Ryan mentioned. And for those, you will need to give write access because, for example, BigQuery doesn't allow you to unload tables unless you create those, like materialize those in BigQuery itself. So, but overall, right now, there is a limiting factor of how many like tables source database can handle, and it depends a lot on database itself. And the second is how many tables can be handled by KubeStore itself. And what we are trying to achieve, we're trying to decouple table count from like performance of KubeStore. And so right now it's being tested on dozens of thousands of tables. And we are going to like accelerate this like even further. So it should be like virtually unlimited, but I guess in a couple of months, given all the performance optimizations we are doing right now, it should be like hundreds of thousand tables that can be handled.
Cool. Yeah, and I'm not sure if Ryan, you covered this. There's a question I'm scrolling back. Is there a way to know whether his query is picked up from pre-aggregations or it was queried directly from the database?
Yeah. So in KubeCloud, this is quite observable. So back on the queries tab, there's this filter where you can see whether, I can filter by whether it was using a pre-aggregation or it wasn't. This is a good way to see when those queries happened, what those queries were as well. So I can click into them and see what the query was in SQL, for instance, as well. And also then take a look at, well, what's the pre-aggregation that I could potentially use to basically serve data from that query should it happen again in the future.
Cool. Okay, I think this one from a few minutes ago, is there a way to use context variables in pre-aggregation refresh keys?
Yeah, great question. And that's actually related to multi-tenancy. So short answer, you can and should use those variables if you want to split pre-aggregation table, then don't reuse across multiple tenants. And if you want to reuse some pre-aggregation tables across multiple tenants, so you should just avoid using like context variables or compile context in these places, just to make sure you like not basically filtering out one tenant if you're using data from another one. Yeah.
Cool. Another question, where are the tables for pre-aggregated data created? Can I manage their names of the tables, I assume? But
yeah, great question. As I just described it, so like tables created in a source database right now for most of data sources, but we are moving towards not creating those by default. And those will be created also in KubeStore. And yes, you can manage pre-aggregation table names. There is a SQL alias pre-aggregation option that you can use to basically control it.
cool. All right, and then this is a pretty broad question. What's the underlying technology for KubeStore?
Yeah, really great questions. Yeah. So under the hood of Cube Store, we use Apache Arrow and Data Fusion. This one is written in Rust. Like technology is relatively new. So multiple companies are working on it, including InfluxDB guys, Influx Data guys. And under the hood, we use Parquet as a storage layer, which is backed up by basically distributed file system. And we support currently S3 and basically um, um, Google Cloud Storage, only two of them, but going forward, we are going to support more. But yeah, overall, it's Data Fusion, Apache Arrow, and Parquet as a storage layer.
Cool. I think we'll do one more from the Q&A, and then we also had questions. I'm trying to make sure I don't forget this. Or people submitted like questions when they register, so we'll go over those as well. So one more from the Q&A. Can pre-aggregated data be joined with non-pre-aggregated Bly dimensions?
Yeah, this is a question we've been frequently asked, and like short answer currently is no. We do not support joining pre-aggregated or merging it in any way with like pre-aggregated and non-pre-aggregated data. So it's still on our plate, and we are thinking about how to address this. And yeah, like we are welcome anyone with these use cases to post it on GitHub and be involved in the discussions there. So we can see all the use cases which require this approach. Yeah.
Cool. Yeah, so I think there were broadly like three questions or like three topics they asked us to cover when people register. I think one of them was high cardinality dimensions and time dimensions. So if you want to quickly address those, that would be great.
Yeah, so this is really category of questions which was also addressed by a question about filtering. So how do we pre-aggregate really high cardinality rollup tables? And the answer to that is using indexes. So in order to approach this in Cube Store, we introduced indexes, and basically those working a little bit different than indexes in like in relational databases. So indexes in Cube Store are copies of your data. So you're paying basically twice while you're ingesting data in terms of like processing cost, like computing cost. However, in terms of querying time, you're basically getting the most like the performance which can be unmatched without like using copies of data here. So, and if you're using indexes, you can basically so indexes essentially is a different sorting order for columnar data, if you're familiar with this concept. But the approach, like simple approach you can use, is basically to put all filtering columns which you're using on pre-aggregation filtering queries in index, and you'll see like significant performance improvement in terms of like serving pre-aggregations, like hard cardinality pre-aggregations queries where you use filters. So this is like simple approach, and it allows you to serve really like hard cardinality tables, so up to 1 billion of rows in it.
Cool. Thank you. And I think this was asked, I mean, in the Q&A as well, or maybe it was in chat, like in general, how pre-aggregation queues work.
Yeah, so as Ryan already showed you in basically in Cube Cloud, you can see those queries on a queries tab and a database tab. So this is database execution queue. So originally, Cube.js has multiple queues, and those work pretty similar. It has query queue for querying actual data, and the same query queue implementation is used to build pre-aggregations. And however, as we're going forward and we have all of those Cube Store optimizations, for example, one of which, like Cube Store doesn't use Redis queue to basically fulfill queries. It's something I talked in the beginning. It allows you to achieve like unmatched performance because all your API instances not interconnected, so there is no latency and fulfilling all the coordination between API instances. But like pre-aggregation queue still using like this query queue implementation. And simple idea is you have dedicated refresh worker which schedules all workload on this queue, and basically main goal of this queue is to limit throughput to your database so it doesn't get swamped. And by default, as Ryan mentioned, so there is very low basically a threshold, like throughput threshold for databases, which can be basically changed in options. But yeah, it's just a very very simple queue that allows to limit the throughput of building pre-aggregations. If you want to really understand what happens under the hood, you just probably want to see it in how it works in Cube Cloud, because all of those controls is very all the visualizations feel very natural once you see those. Yeah.
Cool. And I think the last one was about like reducing costs. And I mean, for example, by using Cube Store plus like refresh node. But yeah, anything you want to add there, Pavel?
Yeah. In terms of reducing cost, so the very simple approach to reduce cost using pre-aggregations is usually, as a rule of thumb, you should see all the queries, like what are the most of the queries hitting your raw data, and it's usually 90% of them. 90% of them can be fulfilled by single rollup table. It's what we see on most of our deployments. And once you build this rollup table, partition it, and configure correct update strategy, what you'll see that if you cut all of this, like 90% of your queries to raw data, and just like pre-aggregation would be fulfilling those, you won't be hitting raw data anymore. And basically cost of pre-aggregation refresh is much lower for most of big data backends. And in terms of latency, it can be even like you can refresh it even like once 5 minutes. But the thing is, when you're like allowing your users to access raw data, you're paying for each request the same price, because it's data access not based on a time consumed usually, but it's based on access itself, the fact of access. And pre-aggregations allow you to basically cut all of this raw data access queries and convert those to single refresh queries, which can be not as frequent as your user access.
Cool, thank you, Pavel. Yeah, so I think like Ryan, just a question for you. I think you may have covered this in terms of like specifying or scheduling when pre-aggregation is refreshed. I just saw that question come up. And then, yeah, I wasn't sure if you wanted to share an example of like a count distinct, but I don't want to put you on the spot, but.
Oh,
yeah.
yes. And we're just, we were cooking this up quickly in the back end.
Yeah.
Give us 1 sec if
Yeah.
anyone else wants to answer a question.
Cool. Yeah, I guess while we're doing that, Pavel, like, yeah, I wasn't sure if this was covered. Like, can you specify when pre-aggregation is refreshed at like a 6 a.m. each morning, or 15 minutes after the hour, et cetera, et cetera?
Yeah, great question.
Yeah.
So short answer, we have a cron syntax for that. So you can go to the docs. It's called refresh key, and you can find cron section there. Yeah,
Yep.
So we support it.
Cool, thanks. Yeah, I wasn't sure if that was one of the things that Ryan went over or not, as I was monitoring questions. But Ryan, if you're not ready, I can just quickly cover the resources slide, because I know we're trying to come up with stuff real time. Give me a second here. I'm gonna.
Okay.
Oh, sorry. Like I'll give you back control. Sorry, but yeah. I mean, just in case you haven't are not familiar with these resources, I just want to mention this, and we'll go back to Ryan. Obviously, I mean, documentation. We're we're making improvements on a daily basis, but just basically go to the caching section, and that you'll see a lot of the topics that that both Pavel and Ryan reference already in documentation. If something's missing, I mean, open an issue or PR and let us know. And there's a blog post that was originally written a while ago, and we'll probably make updates with our latest features. But there's our original blog post on pre-aggregations that gives you a good overview. And in general, I mean, many of you have been very comfortable with Slack and posting things on Discord. So if there are other questions as you're getting started or using pre-aggregations, feel free to post questions. And I've noticed that a lot of the questions are being answered not only by our Cube.js team members, but community members as well. So it's great to see experiences that are being shared by community members. And one final resource, as a lot of these questions came up, I think some of you may have met or heard from Jordan during monthly calls. He's head of our GM of Cube Cloud, and there are a lot of questions about Cube Cloud in general. So, I mean, Jordan, I'll let you answer that question and how people can get a hold of you if they have any follow-up questions on Cube Cloud.
Yeah, thank you. Just to confirm, you can hear me right now, correct?
Yep.
Okay. Yeah, so I saw a couple questions about how does the pricing structure work with Cube Cloud? What does support look like? What are the differences? And I will make sure that Ray actually links me directly in follow-up to the open source channel. And so you can contact me via Slack for more specific information. It really, the quick answer between what are the differences is that Cube Cloud is a managed version of the open source. So it's basically infrastructure plus some additional tooling equals Cube Cloud is what it is. And as you could see when Ryan was going through things, the Cube Cloud actually has a specific drop down or a page dedicated to pre-aggregations. You can do pre-aggregations with open source, but there's a specific area dedicated to pre-aggregations in the cloud. And that's, again, kind of the goal is to add a little bit of advanced tooling to what is already existing in the open source. That's just one of the many things that we're adding. So I probably should have started by saying that I'm the general manager of the Cube Cloud, and I'm in charge of the planning and execution bringing the cloud to availability for you and all those who are able to test it out today. So questions around pricing and support are all specific to everyone's use case and how they actually want to use the product. But I can tell you that there will be multiple levels in which you can engage with us, from basically like workday hours, 9 to 5 support, all the way to 24/7 1 hour SLA support, and those pricing models adjust accordingly. And it's the same thing with our cloud offering. We'll have an offering for those, like a freemium version, people who want to just use the product for free, up to almost like a test or a pilot for you and your team. Then there's also shared or dedicated VPCs depending on your data needs. So I can go into this forever, but I don't want to bore everybody, and it'd be great to get everyone out before the 2-hour mark. So again, I will actually send out my email in the chat after we pass this back to Ryan, and then I will have Ray at me in a follow-up message so people can just click and directly Slack me. That's probably the best way to get in touch.
Cool, thanks for jumping on, Jordan. Yeah, intentionally, we didn't want to make this a sales pitch for Cube Cloud necessarily. We wanted to use it as a platform for the workshop. But yeah, thanks for jumping on, Jordan, to answer questions from the audience. And yeah, Ryan, let me stop sharing, so I'll turn things back to you.
Okay, thank you. Yeah, I just wanted to show an example of the count distinct, which was asked about. So I have a lot of windows open now. So yeah, here in the schema, we've defined pre-aggregation with the account distinct measure, this measure here, and yeah, just the time dimension of the creation at time. And you can see from Playground, if I run this query, which is using that unique count measure and creation time as a dimension, just doing it over the last 30 days. Yeah, I'm getting accelerated query for that. So again, this was how it was defined in the schema for those of you who were interested in that.
Cool, thank you.
Simple. Yeah.
Awesome. Like you're able to come up with this real time. It's just cool. So yeah, and I also added a note on chat as well. Recently created a pre-aggregations workshop channel on Slack, which people also discovered as well. So feel free to, if any questions sort of fell through the cracks, I mean, hopefully we answered, vast majority of them. And if there are any follow-up questions on the workshop, or I mean, Jordan's on there too. So if you want to reach out to like Jordan or myself in the Slack channel, I mean, feel free to do that. Yeah. So yeah, I think that basically covers all the agenda topics that we wanted to talk about. I mean, first of all, wanted to thank everyone for not only registering but joining. I mean, it's well like past like almost 100 minutes since we started, and there's still like 66 people on the workshop, which is above and beyond what we anticipated. So I mean, appreciate your participating. Hope you found it useful and participating with your questions as well. And then, yeah, and feel free to reach out to me with questions, and encourage once again to fill out the post-event survey that'll go out shortly. And then hopefully we'll do this again soon. So, and thank you, like Ryan and Pavel, for leading our discussions today. So.
Yeah, thanks for having us.
Cool, thank you.
Thank you.
Thanks, guys.